Hello, in this video, we'll be discussing 4.3, which is logarithmic function. So this will be the first part of this video. There will be a second part. So what is a logarithmic function? Logarithmic function arises from exponential function. So if you look at exponential function, we have two kinds. This is when a is greater than 1, you have an increasing function. And then we have the second one, which is when a is between 0 and 1, and that will be a decreasing function like this. So in both cases, you will see that what? They are one-to-one function. So it means we can find the inverse. So the inverse of a logarithmic function, of an exponential function, is what we call a logarithmic function, which base is a, and is denoted by log to base a, right? So what that simply means is that if your function f of x is equals to ax, then the inverse, f inverse of x, is just log to base a of x, right? But for this one, it doesn't matter. We know that a is what? What is the condition on a? Usually we know that a cannot be negative, so a is greater than 0 and a is not equals to 1, but x is the whole of real number. But for the inverse function, the logarithmic function, the condition on a remains the same. A cannot be equals to 1 as well. But something that differs here is the x. Here, the x has to be only in what? X has to be positive because we cannot take we don't have a logarithm of a negative number. So what I mean is here, we need to have this restriction. A is not equals to 1, but x has to be greater than 0. We'll talk about this much later. But what do we know? This is just the relationship between the logarithmic function and the exponential function. And this simply comes from where? If you remember, we said if you have f inverse, if I have f inverse of x equals to y, what is the meaning of this? Based on 2.8, you can see that this simply means that f of y is equals to what? A to power, no, f of y is equals to x, right? This is a true statement. And this comes from where? From 2.8. So here, but what is f inverse of x? F inverse of x is what? It's log to base a. So this, we can write it as log to base a of x equals to y is equivalent to what? What is f of y? Look at f of x. F of x is given as a to power x. So f of y will definitely be a to power y equals to x. So it means that we can always move from where? Logarithmic form to exponential form. So this is the logarithmic form, and this is the exponential form. So we have the base, and also we have the exponent. So it's just similar stuff here. For example, if you have log to base 10 of what? This is just the application, 100,000 is equals to 5. Yes, this is a logarithmic form. Now, to change it to exponential form, all you need to do is what? You write it as 100,000 is equals to what? 10 to power 5, which is true. Because this will be our A. This will be A. This is what? This is X. And this is what? This is Y. All right. Okay, so let's another one. You have log to base what? 2 of 1 over 8. This is in logarithmic form. So to write it as you have this equals to what? Minus 3. This is logarithmic form. All you need to do is take this as your x. So 1 over 8 is going to be a, look at it here, is going to be a to power y is equals to x. So what is a, which is 2? So you have 2 to power minus 3. And this is going to be 1 over 2 to power 3. So it's the same, right? So this is to show you that they're all equivalent. So the same here. So now let's see some properties of logarithm. The first property here is that log to base a of 1 is 0. Log to base a of a is 1. Log to base a of a to power x is also x. And a to the power of log 8ax is also a. Now, I'll try to explain these laws briefly here. So now let's start with the first law. What is the first one? The first one says that log to base what? To base a of 1. Now, why is it 0? Let's assume you don't know why it is 0. What should you do? You can say it's equals to what? Let's say m. And what does that mean? It means that if you change this to exponential form, it means that 1 is equals to a to power m. Therefore, 1, you can write it as a to power 0 is equals to what? A to power m. So this means that your m, because they have the same base, so m, it has to be 0. So you can conclude that what? Your m is 0. So it means that log to base a of 1 is equals to 0, right? Then for the second one is similar situation. We know that log, you want to find log to base a of a. We want to find what it is. Let's call it m as well, or you can call it, yes, we can still call it m. So it means that a is equals to a to power m. So what is this a? A is to power 1. So a to power 1 is equals to a to power m. So this implies that m is equals to 1. So it means that you can say that log to base a of a is just 1. All right. So now we have property 3 and property 4. So let's see if we can squeeze it in somewhere here. Right? Now for this one, let's see, we have to use something which we call the cancellation property. If you have a function and its inverse, you know that f of what's, you can say f inverse of f of x, this will always be what? This will always be x. This is from cancellation property. And also, so what does that mean? It means that if you multiply, remember, what is f inverse? Let me write it here. Remember, f of x is equals to ax. Then f inverse of x is equals to what? Log to base a of x. So if we do f inverse of f of x, what is f inverse? So you have f inverse of, what is f of x? F of x is, what is a to power x? And this is going to be equals to x, right? Because f of x is ax. But now what is f inverse of ax? So f inverse of ax, what is f inverse? F inverse means just take log to base a of x. So it means now we have to take log to base a of ax. And this is still going to be x. So you can see that this is number 3. Then number 4 is also from the same story. Remember also that we have f of what? F inverse of x is also equals to x. Where are these two coming from? These two, this and this, these are what we call the cancellation property, right? We call them the cancellation property. We discussed this in 2.8. All right. So let me put it here. This one and this one, they are called the cancellation properties. And this is always true for any function and its inverse. Okay, so let's apply this. So this is f of what is f inverse? F inverse is the log to base a, log to base a of x, and this is equals to x, right? Then f of this, what is f? What does f do? Look at f. F will just be a to power x, right? It just be a to power of x. So now this is standing as our old hex. So this will now be a to power log to base a of x. And this is equals to x. So this is you can see that this is number 4. This is the fourth property of logarithm. So just a quick one. So what does that mean? It means to apply this property, if you have what? If you have log to base 3 of 3, then to power 2, your answer should just be equals to 2. This is by using property number 3. Also, if you have 3 to power log to base 3 of 2, the answer is just what? It's just 2. So these are just the quick applications of these properties. All right, so now let's go to answer some problems. Just 2. Okay, so look at these examples here. Example 3, he wants us to solve these questions. Let me use a blue pen. Now, you want to solve each of the following equations. So to solve equation means you are looking for what? You're looking for a variable. So here, all of them are in logarithmic form. So it means we are looking for x. So all we need to do is, first of all, you go from logarithmic to exponential. We're using, what do we say? We said if you have log to base a of x equals to y, log to base a of x equals to y, this is simply what? This simply means that a to power y will be equals to x. So this is basically what we'll be using here to find these values of x. So this means that a to power y is equals to x, right? So here, what does that mean? It means that 16 over 9 is just what? It's just x to power minus 2. And now this means that 16 over 9 is equals to 1 over what? X squared. Then we can flip both sides so that it becomes 16. Now 1 over 16. This equals to, not 1 over 16, this is 16 over 9. So this becomes 9 over 16 equals to x squared. So x will just be plus minus 9 over 16. All right. And so with this, you can see that x is plus minus 3 over 4. But if you look at the position of x, you see x is standing as the base, right? Which is like the position of the a. And we know a cannot be negative. So we have to take that what x is equals to what? The positive one, which is 3 over 4. Yes, this is since x is what? Since x is greater than 0. And x is the what? The base, which is a. Oh. So similarly for the b, we do the same. This means that we can write it. Our x is going to be 16 to the power 3 by 4. Right. So what do we have here? Now it means your x is equals to 16. This is like saying the fourth root of what? 16 all to power 3. We can make it that way. So, but what is this? So this we can write as the fourth root of, this is 16. How can we write 16? 16, we know it's, so we actually have 2 to the power 4 times what? Times 3, right? So we can see that this is going to be, you can have it as, what does this mean? 2 to the power 4. So you can have 2 to the power 4 times 2 to the power 4. How many times? Times 2 to the power 4. And now, which is like 2 to the power 12. So if you want to take, what does that mean here? It means 2 can come out. Also, 2 can come out. And then also 2 can come out because the power there is what? Is 4, right? Yeah, so you don't need to have any. And here we're going to work with what? We're going to go with the positive one because of the position of what? The position of x. The x there cannot be negative. So as you can see, our answer should be just what? Should be just 8. So x is going to be 8. Yes. Now, if we look at this one, for this will be 36. Is equals to not 36, but root of 6. The root of 6. Okay. So pen is, so here we have root of 6 is equals to 36 to power x. And now this we can write as 6 to power half. 1 over 2, it's equals to, this we can write it as 6 to power 2 all to power x. So we have 6 to power half. 6 to power 1 over 2, it's equals to 6 to power 2x. So here now we can drop the powers, we can drop the bases. So we have half is equals to 2x. And that simply means that what? 1, it's equals to 4x. And this means that our x is equals to 1 over 4. So in example 4, we're just to evaluate, because here it's not talking about solving for x. It's not saying, it's not an equation. So we want to evaluate. It means we want to know the value. What is the value here? So what we do here, we can equate this to be, let's say we can equate it to be something. Well, let's say we can equate it to be m, or you can use any letter of your choice. Now this means that what? 8 is equals to 8 is equals to 0 point what? 0 0.5 to power m. Yes, 0 0.5 to power m. Now, once we have 0 0.5 to power m, so all we need to do is to what? Is to write, what do? We try to write things in terms of power. All right, so here we can have, it means that 8, we can actually write this as half, 1 over 2 to power m, right? And this we can write as 2 to power 3. These as well, we can write as 2 to power minus, so this can be minus m. So it means that 3 is equals to minus m. In other words, m is equals to minus 3. All right, so for this should be B. Now for B, we can do similar stuff here. We still use this. Here we can say, okay, we let what? You can let log of the cube roots of 16 by 4. Let's use another letter this time. Let's use n. So what does this mean? This means that cube root of 16 over 4 is going to be 4 to power n, right? And what that means is, if we can find what is m, remember here, we got what is m, so you can conclude here that log to base 0.5 of 8 is actually minus 3, because that is what m is. So here, let's come back here. This we can write as the cube root of 4 square. Yeah, because 16 is 4 square. So the goal is to write everything in terms of 4. And then you can write the numerator as 4 to power 2 over 3 divided by 4. That's equals to 4 to power n. So this is 4, this is 4. You can subtract the powers. So you have 2 by 3 minus 4. It's going to be 4 to power n, right? And let's finish it up here. So this is just going to be 4. So did I say minus 4? No, minus 1. Because we are subtracting the powers, right? Yes. So this is going to be 4 power minus 1 over 3, right? Because 2 over 3 minus 1 is minus 1 over 3. And this is simply equals to 4n. Then the bases are the same. We can drop the bases and we go with the powers, the exponent. And this will be this. So it means the n is minus 1 over 3, right? But what is n? We can conclude, because here we just let this to be n, so we can conclude that log to base 4 of the cube root of 16 over 4 is equals to minus 1 over 3. So here it's 1 over 3. Okay. All right. So for C is similar. You can say let this log 0.3 of 1,000 divided by 27. Let's let it to be x. You can use any variable of your choice. Now you convert to exponential form. You can say 0.3x is just 1,000 over 27. And now this means we can write this as 3 over 10 to power x. And here, if you look carefully, you can write 1,000 as 10 over 3, all to power 3, right? Okay. But here now, if you look at the basis, here is 3 over 3, here is 10 over 3. So we need to flip one of it. So if you flip the right-hand side, this is 10 over 3. If you write it as 3 over 10, then there has to be minus 3. Okay. So we're done. Now you have 3 over 10, 3 over 10. So your x is going to be minus 3. Now, if x is minus 3, what does that mean? It means that the log to base 0.3 of what? Of 1,000 divided by 27. You can put it in brackets. You can put it this way to avoid confusion. Now, this is what? This is equals to x, but x is minus 3. So you can see this as the final answer. All right, now example 5 says that what? Let f of x be equals to log to base a, log to base ax of this. We want to find f of 2. No, f of 2 is given, so we want to find f of 4. Now, just start from here. If our f of x is giving us log to base a of x, use the fact, use what we have. What does this mean? This means your y is 3 and your x is 2. So it means that 3 is what? Is going to be log to base a log to base a of what? Of 2. You see? So what have we used here? We have used this point. The point x is equals to 2 and y is equals to 3. So clearly here, it means that a to power 3 is equals to 2. And then our a is just going to be the cube root of 2, right? So what does that mean? It means our function f of x is nothing but log to base what's a, but a is the cube root of 2, then of what's of x. So this is our function f of x, right? Now that we have f of x, we can find f of 4. So what is f of 4? F of 4 is just going to be what? So we're moving from here to here. F of 4 is just put x to be 4. It will be log to base the cube roots of 2 of what? Of 4. So we need to know this value. And then we can do the same thing we did. So we don't know this value, so we can say, okay, let this value itself, just similar to what we did in previous examples, let this be equals to m. And once we let this to be m, then we can change from logarithmic to exponential. So when we change to logarithmic to exponential, you can see that this will be the cube root of 2 all to power what? M equals to 4. This is 2. Yeah. All right. So what can we do? What is the meaning of this? This is cube root of 2 is nothing but 2 to power 1 over 3, everything to power m. And this we can write as 2 to power 2, right? So this means that 2 to power m over 3, it's equals to 2 to power what? 2 to power 2. So we can drop the base now. So m by 3 is equals to 2. Therefore, m is equals to what? 6. So it means that if you come back here, our solution will be, because m is equals to 6, so we can conclude that that f of 4 equals to 6. Yes. So let's go to the next example, which is example 6. For example 6, we want to find the We want to find the inverse. So we have exponential function, we want to find the inverse. So we just follow the procedures we saw in 2.8, how to find inverse, right? So step one is just to make what? Is to make y. So we can write y equals to 1 over 2 to power x, everything minus 2. This is step 1. Then step 2 is now solve for x, right? How do you solve for x? So you have y plus 2 equals to what? 1 over 2 to power x. Then now you have to solve for x, but here we cannot solve for x by comparing the bases, because the bases cannot be the same. So we can take logs. So you can take log to power 1 over 2 of y plus 2 is equals to log to power 1 over 2 of what? 1 over 2 all to power x, right? And here we can use the fact that this will simply become x, right? because already we saw in one of the property that if you have log to base a of a to power x, it's just what? It's just x, right? So here, it means that x is what? Log 2 power half of what? Y plus a 2, right? Okay, so what is x here? It means that we have this one. So let me rewrite this. So x is just log to power 1 over 2 of y plus what? Plus 2. So now we can interchange x and y. It means our y is equals to log half of x plus 2. And now this is going to be our f inverse of x, which is log half x plus 2. And now it's good we know the domain, right? What is the domain of f inverse? The domain of f inverse, it comes from the range of f, and you can see the range of this is going to be -2 to infinity. Or you can see here, this is x plus 2, right? This is x plus 2 here. This x plus 2 cannot be negative. Remember, when we define logarithm, we said that this x here has to always be what? Will be positive. It cannot be 0. It has to be positive. So it's just like saying x plus 2 has to be greater than 0, which means that x has to be greater than what? Than -2. All right. So number 7, it's another one here. Let's go for the green here. So here we have f of x is this. The same way, we just need to set the y to be what? To be log 2x plus 1, right? And now you can solve for x, try to solve for x. This becomes y minus 1. Y minus 1, it's equals to log to base 2 of x, right? So how do we solve now? Remember here, we are in a logarithmic form, and then we can go back to exponential form. If I want to go back to exponential form now, it will just be what? 2 to power what? Y minus 1 will be equals to what? Will be equals to no log again, equals to x. Remember, if you have log to base a of what? Of x equals to what? Y. How do you go back to exponential? Just take the base and raise it to power y, right? So here our base is 2. So we're going to raise it to power y minus 1 is equals to x. So you can see we are back to exponential form. So we have what is x. So now at this stage, we have to interchange x and y. So it means that 2x minus y is equals to what? Is equals to y. And that is our f inverse. So we can conclude that what f inverse of x is just nothing but what? 2x minus 1. And this, what will be the domain here if we want? This is an exponential function. The domain is the whole of R. So this is fine. Okay, so now just to finish it up here, then here what we're discussing here is about common and what natural log here. So what is common and natural log? If you have log to base what? Log to base a of x. So if you take your base to be 10, so if a is equals to 10, so if a is equals to 10, it means we will have log to base what? 10 of x. So this is what we call the natural log. And this natural log is the same thing as writing it as just log what? Log x without the base. So anytime you see a log without the base, it's referring to what? Sorry, not the natural log, the common log, I mean. So it's called the common log, this one, common logarithm. That is to base 10. So this is what we call the common logarithm. You can call it common log in short, or common logarithm. Now, if you take a to be equals to e, remember e, we discussed e, which is the number e, 2.71 something, right? Okay, so here it means it's going to be log to base e of x, which is equals to log to, what is log to base e? Log to base e, another name for it is the ln, which is the natural log. So you have ln of what? Of x. So this is what we call the natural log. All right. And now you can see that all these properties still hold. Look at this property, property a to properties a to d, right? So I will just quickly highlight these properties here. So this, it's already getting longer, but let's just finish this up here. So this is lane one. Remember, we one of the property we saw is that anytime we have what? Log to base a of a is equals to what? 1. Yes. But now, if you let your base to become e, so change a to e, you will have log to base e of e equals to 1, right? So it's the same. But what is log to base what? No, this is not the one I want. I want the first one, which is log to base a of 1 is what? Is 0, right? Yes. So I'm just trying to replace a with e. So log to base e of 1 is also going to be 0, yes? Because this is for any a, right? And now, what is log to base e? Log to base e is nothing but natural log, so which is ln. So it means that ln 1 is equals to what? 0. So that is why we have this property here for natural log. So in the same manner, we also saw that if you have log to base a of a, it equals to 1. This simply means that what? If I change a by e, replace a by e, you have log to base e of e is equals to 1, right? But what is log to base e? Remember, log to base e will become ln. So this means that ln of e is equals to 1. So that is why we got this one, right? Then the third one is that what? We also saw that if we have log to base a of ax, this is nothing but what? But x. So now if we change a to e, replace a with e, it means we have log to base e of e to power x is also going to be x. And this is simply because log to base e of e is nothing but what? Log to base e is ln. So you have ln e to power x is going to be just x. And that is why we have this property. And finally, we also saw that if you have a to power log to base a of x, right? We have this one, right? We saw that this is also equals to x. So if we replace a with e, you have e log to base e of x, right? And what will this be? This will just be e ln of x, which is equals to to x because we also have this is our lim of x. All right, and we have the fourth properties. All right, so I think this is enough for the first part of this video. And the second part, we'll be looking at how to sketch the graph of logarithmic function. So thanks for watching. I hope this is helpful. Thank you for watching. If you have any question, you can put it in the comment section. And if you have not yet subscribed to my YouTube channel, kindly do that and turn on the notification bell. Thank you for watching.